Hello students, welcome. Previously, lesson 3, form 4, topic 3, we were dealing with factors affecting the rate of reaction. So today, lesson 4, we are going to start with determining the rate of reaction using tangents and also gradients. Students, rate of reaction is achieved by drawing a tangent to the curve on a graph and using the gradient to determine the rate of the reaction. Remember, during the KCSE, students are expected to draw tangents and calculate the rate of reaction at a specific time. Or they're asked maybe to look for the rate of reaction between certain times. Okay, let's start with example 1. We are told in an experiment to study the rate of reaction between zinc and hydrochloric acid, 0.5 grams of the zinc powder was reacted with excess 2 molar hydrochloric acid, and the data in the table below was recorded. So we're having here time in seconds, and we're having volume of gas evolved in centimeter cube. Remember, the gas that we're talking about is hydrogen gas, because when a metal reacts with hydrochloric acid, we are going to get salt and hydrogen gas. So we're having here the time with interval of 5, and these are the volume of the gas or the hydrogen gas evolved. So the first question or part A of the question, we are told write the equation for the reaction that takes place. Here we are dealing with zinc reacting with hydrochloric acid. So we are supposed to write zinc, and zinc is solid, reacting with hydrochloric acid, HCl, aqueous. Here we are going to get zinc chloride, aqueous, plus hydrogen gas. So we are supposed to balance the equation, and we are supposed to put 2 in the side of hydrochloric acid to balance the equation. So next, we are going to go to part B. We are told plot a graph of volume of gas evolved against the time. So here, we are supposed to use the table given. We use that values to draw the graph. Okay, students, have a look on the values given and try to draw your own graph. So me, I've taken my values and I've drawn my graph, and I've used the scales in x-axis. I've used 1 centimeter square to represent 5 seconds. On the y-axis, I've used a scale of 1 centimeter square to represent 5 centimeter cube of volume. And I've drawn, and this is how the graph look like. So I told plot a graph of volume of gas evolved against time. So if you check on the x-axis, I have time, and it's measured in seconds, and I'm having a scale of 1 centimeter square to represent 5 seconds. On the y-axis, I'm having volume of gas evolved in centimeter cube, and this is the scale I've used, 1 centimeter square to represent 5 centimeter cube of volume. So this is how the curve look like, and if you see this point at 40 degrees Celsius up to 55, at 40 seconds up to 55 seconds, the curve is horizontal, meaning that the reaction was over or complete. Okay, after that, we are going to go to part C of the question, and we are told determine the rate of reaction at Romeo 1, 8 seconds, Romeo 2, at 25 seconds. So to determine or to calculate the rate of reaction at a specific time during a reaction, you are supposed to draw a tangent on the curve at 8 seconds. Okay, where is 8 seconds? 8 seconds. 8 seconds is here, so we go on the curve, it is here. 8 seconds. Remember, this is 5, so 6, 7, 8. 8 is there. Then, when you have to draw a tangent. How do you draw a tangent? We take the ruler and we put it in that point 8. Then we make a line. We make a line like that. Then we are supposed to draw a triangle so that we calculate the gradient of that point. Okay, we can pick any point. Okay, let me take from maybe from here. I hope it is visible. Then I can have my triangle on this other side. Okay, I've formed now the triangle. This is the triangle. So how are we going to get rate? Rate is given. Rate is given by calculating the gradient of that tangent, and gradient is given by change in y over change in x. Then that means change in y, we mean y2 minus y1, then divided by change in x, we mean x2 minus x1. Okay, from there, what is our y2? We are going to see the triangle that we have drawn there. This is y2. So y2 here, if we read this value there, we are having 40 here, 41, 42, 43, then we have 43.5. So this will be equal to 43.5 minus. What will be y1? Y1 is here. Because y is the y-axis here, the volume of the gas evolved. So here we're having 10. So minus 10 divided by x2. So x2 is here. So you go with this because this is the x-axis. It is 15 seconds. So we're going to have 15 minus. What about the x1? X1 is here. X1 here, we're having in between 0 and 5. That one we can say this is 1, 2, then it is 2.5. 2.5. So 43.5 minus 10, we are going to get there 33.5. 33.5 divided by 15 minus 2.5, we are going to get to 12.5 there. So if we put this in the calculator, if we put these values in the calculator, we are going to get 2.68. So what will be the unit for this rate? It will be centimeter cube per second, because the volume was in centimeter cube and the time was in seconds. So we go but Romeo 2, C Romeo 2 at 25 seconds. So we go 25 seconds on the x-axis, it is here. Then we move and we see where it's cutting the curve, it is here. So we are supposed to draw a tangent. How are we going to draw the tangent? The same. We are supposed to take the ruler and we put on that point, then we are going to make a line. Okay, thereafter we are going to draw a triangle from any point. So I can decide to take from there, to draw the triangle from there, from that point. I think you can see I can draw up to that point. Then I draw on the x-axis that line to see the triangle, how it will look like. It's like that. So let us see the formula for calculating rates. We said rate is given by calculating the gradient of that curve. That's change in y over change in x. Then we're talking about change in y. We mean y2 minus y1 divided by x2 minus x1. So next, let's see now what will be our y2. So we can check the triangle that we have drawn at 25. Let's see the triangle at that we have drawn at 25th second. It was here. Then that means y2 is here. So this is 55, as you can see there. So if it is 55, we have 56, then that's 57. So we are going to write 57 minus 57 minus, then we see y1 is here, and this is 40, as you can see. So we are going to say 57 minus 40 divided by. So next, we are supposed to look for the x2, that's we are having here 45. So we are going to write 45 seconds minus. What about x1? X1 is here. So let's check whether it's cutting. It's cutting here. And here is 10, 11, 12, 13, 11, 14. So it's cutting at 14. So we say minus 14. So this will be equal to, so 57 minus 40, we are going to get there 17 divided by, here 45 minus 14, we are going to get 31. So if we use calculator, we are going to get as our answer as 0.548. So what will be the unit? The unit will be in centimeter cube per second. Remember, the volume was in centimeter cube, and that time was in second. So we're done determining the rate of the reaction at 8 seconds and at 25 seconds. That's how you are supposed to calculate. So next, we are going to go to the next page. In next page, we're having part D of the question. We are told explain the difference in the rates of the reaction in C above. As you can see, we are having at 8 seconds, we are having 2.68 centimeter cube per second as our rate, and at 25 seconds, we are having 0.548 centimeter cube per second. That means at 8 seconds, the reaction is faster when compared to at 25 seconds. We see that. Okay, how are we going to explain that difference? So we are going to say the initial rate, that's at 8 seconds. So we are going to say the initial reaction at 8 seconds is higher, because we have seen it, is higher than the rate of reaction at 25 seconds. Reason? What is the reason? This is because initially there is a higher amount or a higher concentration of reactants, but the amount of reactants or the concentration of the reactants decreases with time, and therefore the rate of reaction decreases as well. That's the explanation for the differences in the difference in the rates of the reactions in C above. That's the end of our video.